Welcome. I'm really happy and actually surprised to have so many people here at 4 o'clock. Usually in Finland at this time it would be an empty room, and that's probably the reason why Finland's economy is going like this and Estonia going like that. But I'm happy to see you. In the next about 45 minutes we will talk about what is hyperconverged and especially what SimpliVity is doing there, and as one example of a good example where we can use SimpliVity functionalities to how to cope with those CryptoLocker attacks. Then we also have one of our customers, Atea customers locally here, Tallinn Technical University, who has been one of the pioneers here using SimpliVity technology, probably one of the first. Atea was probably the first customer, and then they followed. So long-time SimpliVity users, they will tell a little bit about their experiences with SimpliVity solution. So let's not use more time a fast introduction. I'm Kristian, as was told. I've been at SimpliVity for 2.5 years. Before that, I was at EMC, the late EMC, for 10 years, and a technical guy taking care of disaster recovery and those kinds of solutions. So let's go into the actual presentation, like this. So when I started with SimpliVity, this was basically the answer, the question that I got most. That what does hyperconverged architecture mean? And to put it shortly, like everyday people's version of the answer is that we all remember when we had mobile phones like that one, and then at that time we had camera, a calculator, a separate music device, etc., etc. All these different devices to be able to do all these different kinds of tasks. So then came these smartphones, and basically it's a single device that does all those things where you needed all these separate devices before in a lot easier and simple way. So same kind of trend is now happening also in the data centers. So it's been too complicated, too hard, and something needs to be done. So Gartner is actually talking about these kind of technology waves that coming, and a technology wave is something that when the wave starts, it is the year when that kind of technology kind of takes the big step that most of the data centers are built using that kind of technology. For example, in 2005, blade servers. Most of the data centers that we are using nowadays are using blade servers, and it has been a huge wave in the technology market. Those changed a lot of the way we did physically those data centers. Then the next wave was these integrated systems, or converged infrastructure, which means basically those from NetApp FlexPod systems, EMC vBlocks, those systems where you bought a rack and you have pre-configured server storage switches that came from those big companies. Then the third wave is basically this year. And Gartner says that this is the year when most of the new data centers are being built with hyperconverged architecture. And also most of the data centers are being refreshed. And it has been really, we have the pioneers like Tallinn Technical University who were brave to take the first steps, and now is the big wave coming in, and it has really been seen in the business what SimpliVity is doing. And this hyperconverged wave kind of took the markets by surprise. So if you look at the hyperconverged markets, the companies that you are seeing in the top right corner are not the companies that you are used to see as market leaders, like those old big IBMs and HPs and EMCs and Dells. It is companies that nobody basically heard about like 5 years ago. So SimpliVity, Nutanix, Pivot, etc. Are the current market leaders in the hyperconverged architecture. So let's talk about the data problem. What's the issue? Why did these hyperconverged systems came to the market? As I said, it's because most of the data centers, it's really, really difficult to operate them. You have all those different components that you have to configure. And how these systems have been built in the past. So we all remember the time when most of the applications that we ran basically have dedicated servers, like physical servers, memory, storage, and compute per application. In that time, the problem was that if you ran out of capacity here, there was no easy way to borrow the capacity from the neighbor system. Then came these centralized storage systems that helped a lot. So basically now you have a dynamical pool of storage that you can give this storage capacity to all these physical servers. A few years after that came VMware with the excellent idea of doing basically the same thing with CPU and memory. Put a fast x86 servers there and a hypervisor on top of that and run the servers as virtual machines. And now you have a dynamic pool of CPU, memory, and storage. And if it is a very important environment, just replicate them into 2 data centers. So this was the basic architecture of most of the data centers when virtualization came to the market. And it was a good solution and made life a lot easier. But this was the time when VMware came out, the average size of the VM, a virtual machine, was about 8 gigabytes. It was doing DHCP, name services, and stuff like that, like a remote edge of the network work. But nowadays, in the data centers, you run your most critical applications, your ERP systems, your important databases, everything virtualized in many cases. So the amounts of data that you are running here in this stack have gone from gigabytes to terabytes to 10 terabytes to hundreds of terabytes in biggest environments. So when you start to have this data problem, large amounts of data, you start to see problems, I/O-related problems in this stack. For example, how to replicate between two sites. The solution, if you had long distances or thin lines, there was a solution in the market with these one accelerating systems. Really systems like from Riverbed, etc. Excellent products doing that stuff. Then you have the backup problems. If you have 10 terabytes of production data, you need to 1 year backup rotation, and with tape systems, that would mean like 100 to 150 terabytes of tape. There was a solution. Data Domain and those boxes came to the market with excellent deduplicating backup systems. Then there's the public cloud, Google, Amazon, Azure. There are different kind of cloud gateways, how to get data to public cloud. And then there's the performance problem. If you are using spinning disks and you need tens of thousands of IOPSs, you get all flash cache, flash cards to the servers, flash to the storage, and then all those disaster recovery and backup softwares. So my American colleague actually calls this slide with the name of accidental architecture. And it's actually a good name because every time we have had a problem with I/O, with IOPSs, somewhere in this stack, the answer from the market has been that don't worry, there is a box for that. and in the end, we are in the situation that there's a lot of boxes for everything. So this has become really complicated. And on top of that complexity is the fact that if this is the legacy stack, the old way of doing stuff, each of these layers, each one of them need power, cooling, floor space, licensing, bandwidth, support, maintenance, etc. Each one of them. And you have to manage and orchestrate all of this. So no wonder everybody's talking about, forget it, I'm going to cloud. But that's not the answer for every place. In some place, you need the performance, you need the control to run those in local premises. So in comes the converged architectures. And there has been an evolution here also. So if this is the legacy way of doing data centers, like 6-7 years ago, when I was at the IBM, I was at IBM 20 years ago, I'm an old guy. But when I was at EMC, these systems came to the market like vBlock and NetBlock, what's the name? FlexPod. The basic idea there was that let's take those legacy systems and repackage them already at the factory. So a customer can choose that, okay, here's the small rack, medium rack, or a large rack. And it made the kind of purchasing and the operating a bit easier. Good products. But if you look at the actual architecture, the physical hardware architecture, nothing has changed. It's still the same systems. It's still the architecture that was actually designed before virtualization. So the first kind of way of where the actual architecture change is the way those large cloud operators are doing their data centers, like Google, Amazon, Azure, etc. They do not have centralized storage systems anymore. They are using basic x86 technology, and from the internal disks of those nodes, they use software to build a virtual storage that all those hosts can see and utilize. The basic kind of commercial versions of this approach, there is VMware's own excellent vSAN, there's Nutanix, a nice product, Pivot, SpringPath, HyperFlex, etc. There is a plethora of software-based storage systems in the market, or software-based converged systems. The problem with this is that when you are using only software to build your storage, you're actually fighting for the same resources as you are using to run those VMs. Because you need to get the engine from somewhere, and these systems are using the x86 CPUs that are designed to run applications, not storage in a way. So the problem here is that if you want to do backups, buy a backup solution. If you want to do remote replication, buy a one accelerator box. If you want to do cloud gateway, there might be a box for that also, etc. So it's kind of a partial converge. And what SimpliVity is doing is that we tried to figure out, and that's why it took 4 years to develop, over 10 patents, to figure out how can we do all the services, all the functionalities that we have in this legacy stack, but make it as easy to run as it is to run a cloud, like your solution in Amazon. Super easy. So what SimpliVity is doing is basically bringing all the functionalities that you had in the legacy into this really, really simple approach. You have a basic x86-based server, and inside that server you have the SimpliVity OmniStack. And with that OmniStack, you get, of course, the CPU and memory resources for the ESX host, but on top of that, you have fully HA, high available redundant storage that is deduplicated and compressed in line. So before anything is written to the disk, everything is deduplicated and compressed. You have image backups, image recoveries, full backups, not snaps, backups. You have image file-level restores, you have application-level restores, you have one acceleration between the sites, you have cloud gateway, etc., etc. So all the functionalities to run mission-critical applications. Oh, sorry, I'll jump one slide. So we also guarantee the functionality. So in our warranty, the small text that nobody ever reads, in our warranty, we promised the next things, the following things. Because we deduplicate and compress everything in line, we promise that SimpliVity systems save over 90% of storage and backup combined compared to the legacy stuff. If this doesn't happen, we bring more hardware. The next one, as an old backup guy like me, we promise that we back up and recover a 1 terabyte VM in less than 60 seconds, every time, always, in our warranty. 1 terabyte VM in less than 60 seconds. And the rest of the stuff is basically how easy it is to run, how easy it is to scale, etc. So we can start with 2 SimpliVity nodes to have a fully HA data center, or we can build large data centers. One of the great wins that we did have this year was one of the global 50 finance houses in this world. It is a regulated finance, like a bank, but a finance, global finance house. They used to have, in the beginning of 2016, they used to have 6 data centers. 2 in US, 2 in Europe, and 2 in Asia. Using classical legacy stack. With servers, with storage switches, storage, backup systems, one accelerator, backup software, etc. All these components that we are used to build data centers. All this was consolidated into 3 data centers. 1 in US, 61 SimpliVity OmniStack nodes, 52 in UK, EMEA, Europe, and 12 in APAC. And this is a regulated finance house. They did a POC, proof of concept, that took a year, 1 year. They tested everything, their ERP systems, the critical banking systems. So they are running Oracle, Microsoft, all the banking applications, VDI, Citrix, Dev and Test. And they calculated that in 5 years they will be saving $100 million. Physically, and as a technical guy, I love this slide. This picture was taken in July. This is one of the 2 rows of racks in their US data centers that they had in the beginning of this year. So there was 34 racks of blade servers, Sun switches, servers, storage appliances, etc. Everything that was running here is now running in 3 racks of SimpliVity hyperconverged nodes. Everything that was running here is running here, and they are doing backups between US and Europe, and Asia and US, between continents. So now you can probably see why Gartner says that this is the 3rd wave. Something big is happening. The way that we have built data centers, which is super hard and difficult, is not difficult at all anymore. And everything is operated with one user interface, which is the vCenter. So as a VMware administrator, you can run your whole data center remotely, all sites. So how does this work? So what's the magic? There are 3 basic building blocks how we do this. One is that we have an OmniStack accelerator physical PCI card inside those nodes. So we are not using the x86 CPUs to do those deduplicating and compression and all those storage operations. We have an engine inside the nodes. It is protected for power loss. All the data is written through 2 nodes and 2 cards to 2 RAID 6 protected disks. So we have a fully redundant HA storage starting with 2 nodes. So everything is deduplicated, compressed, and optimized before anything is written to the disk. The second principle is that we have a single user interface. For VMware, it's the vCenter. So there's a vCenter plugin that we use to do all those storage functionalities, backups, and recoveries. For Hyper-V, it's VMM. So we support Hyper-V, or actually start supporting Hyper-V now than the 2016 is out. And the third thing is that it has a built-in data protection. So we can have a recovery point objective in minutes, so we can do full backups every 10 minutes without causing any IOPS to the storage. So the systems are running, we do backups every 10 minutes without doing any storage load. You will see that in my demo. We can have recover time objective in seconds. So a full 1 terabyte recovery, we promise in our warranty that it takes 60 seconds, but usually it takes just a few seconds. And with 2 nodes, you can have synchronous replication for HA locally or remote. So how does this work? The SimpliVity OmniStack node is a basic x86 server. Inside that server, you have CPU, memory, and storage. And then you get the ESXi installed at the factory. So it is a full ESX host with all the data center functionalities in there. And between the ESX and the actual hardware is the SimpliVity data virtualization layer. And in the heart of the data virtualization layer, there is the SimpliVity Data Accelerator card, as we went through. And the data virtualization platform, we can actually divide it into 2 layers. We have the presentation layer that actually shows up as a storage to the ESX. And then we have the data management layer where we do the data virtualization. And the way this works is that I have these 4 boxes up there, which represent 4 virtual machines. First of the VMs does a write. That write, of course, gets registered as a change into the VMDK file in the data store. But what happens in the data management layer is that we will check that do we have this 8K block physically on the disk. If we do not, we compress it and write it to the disk. Same thing, a new write from another VM, it registers as a change into the VMDK file. In the data management layer, we'll check that do we have this 8K block? No. We compress it and write it to the disk. Same thing the third time. Do we have it? No, we don't. We write it to the disk. Now we get a new write from the new VM. We check that do we have that? Oh, we have that. I do not have to do a physical write to the disk. I just mark it into the metadata that this physical block belongs to that VM and also to that VM. We get another duplicate write. Again, we find out that, oh, I have received that 8K block from somewhere else in this cluster earlier. I do not have to do a physical write to the disk. So when all the VMs are running in full production, they are writing to the data virtualization layer, full speed, but we only do physical write to the disk if some of those VMs has managed to generate an 8K block that we have not received from anywhere else in this cluster. So what do we get from this? 2 things at this stage. One, we get a really, really good write performance because the whole performance of the back end is dedicated to only totally new writes. So we don't write anything to the disk unless it is a totally new block that we have not received from anywhere else. Second, what we get a really, really good capacity from the storage because everything is deduplicated and compressed as when the data was born. On top of that comes the data virtualization concept. So let's say I have 2 data centers. Here I have 3-node cluster. On that side, I have 2-node cluster. So a virtual machine on top of the SimpliVity OmniStack actually is a block map pointing to those deduplicated blocks that are then protected by RAID 6 per node and with network RAID between the nodes. So a VM is a block map pointing to these deduplicated blocks. If I do a full backup of that VM locally, I'm just copying the block map. It takes like seconds, and we didn't do any I/O. If I do a remote backup, I'm sending that block map, that metadata to the remote side, checking what deduplicated blocks I already have received there from the local VMs, and use those. And if I don't have some of the 8K blocks, I need to send them over the network. And if I want to do a fast recovery of that VM there, I just register it as a VM to the vCenter. So what the SimpliVity data virtualization is actually doing is that we separate the virtual machine from the physical data. And all the operations for VMs, cloning, moving, doing new VMs from a template, is done with the metadata, with the block maps. And we only do physical I/O if it's absolutely necessary. So, and that makes all the operations super fast. So what about the CryptoLocker then? I promised to talk about this one. So we have had a lot of customers who, has anybody of you in your organization met CryptoLocker yet? Look around you. A lot of hands go up. So this is really bad stuff. And what usually happens that if this hits your server, you need to either pay and hope that they fix it or go to the backups. We had a company in Finland who was hit with a CryptoLocker, and it took them 3 days to go back to the business when they started to recover everything. With SimpliVity, the recovery is because restorations take seconds. And you can restore locally or to a DR site. So we actually have, oops, wrong direction. We have a customer you can find this actual user interface. I'm not going to read it. Don't read it here. The basic idea was that this is credit union in US, which is a large organization. They were hit with a crypto locker, and luckily that server was running on SimpliVity. It took them 20 minutes to get back into the business. They just removed the machine, recovered from SimpliVity in 1 minute, and then they did some database checks, etc., and everything was working again. So it's a super, super fast way to get back to the business, and we can do full backups every 10 minutes. I know I'm a bit over the time, but I was promised that I'm not going to be pulled from here because I'm the last guy. Plus, I know wrestling, so. So the last thing that I will show you is the actual demo, just a very, very fast, and then we give the stage to the Tallinn Technical University. So just to show you how I would recover a VM if I would have been hit by a crypto locker. So let's go into my demo environment. Just a second. And then I need to remember the password. Yes. Okay, here's my vCenter. So let's say that this is the VM that was hit. Let's check the summary. This is 496 gigabytes, so half a petabyte virtual machine. And if I want to recover it, I go to Manage. Here are all my backups. I'll choose a backup from there, for example, restore a VM, choose which data center I want to restore it, locally or to a remote data center, press OK. You will see that the recovery started there, it's done. Half a terabyte VM. Here is my recovered VM. Let's take this VM, which is a new VM for VMware, and let's do a backup of that VM to another data center. Backup a VM, not to the local data center, but the St. Louis data center. Half a terabyte VM to a remote cluster, 2 seconds. So what happened in the background, the block map of that VM was sent to the other data center, and in that other data center, it took the block map, looked into the storage and says, oh, I have all the blocks I need here, because we have done backups earlier between the sites. And then it says, oh, I'm fine. Backup is ready. And it was because this was a backup from a new or clone of a new machine. For VMware, this VM was new, so there was no way that on a VMware level there was a kind of a full backup of that VM. But it was mapping the blocks to all the existing blocks on the remote side. So really, really cool stuff. Come to the booth if you want to see a longer demo. Because I'm running out of time. I will change the presentation now, so please welcome to our beloved customer who's been using SimpliVity for a long time, and you will get his view probably on the local language.
Shall we do it in English and Estonian? Who here does not understand Estonian? We have one. Võime siis jätkata. Sorry? Võime siis jätkata eesti keeles Toomas Lepik TTÜ-st, kes siis oskaks kohe jätkuks rääkida sellest, kuidas SimpliVity tema organisatsioonis on kasutusel olnud. Aga ütleme, well, let's say thank you very much to Kristian Salo with a big applause.
Hello.
But please stick around if there will be any questions.
So. One question. Can you show me how to start the presentation here? It's not a joke, actually. I will speak in English, to the respect of our English speaker guest here. And hello, I'm Thomas from Tallinn Technical University. And indeed, thank you for this exceptionally technical and detailed presentation of SimpliVity. The thing is, I'm not going too much into the techniques because I'm representing more or less the business side currently, because I work as a CIO, and I'm going to tell you a little bit It's like a love story. Why and how did it happen that we came into love with hyperconverged infrastructure? The how part is more interesting a little bit later about that, but a little bit to introduce who we are and what is the complexity that the university, a modern technical university, actually faces. We are rather big, actually, compared to with regular Estonian small companies. We have close to 2,000 employees and 11,000 students. And when we are talking about our IT services office, who is actually serving the entire university, then you can see that we are always in the lack of resources. And that's why this SimpliVity and hyperconverged really came into and helped us. So basically what you see here is that this is our service catalog. It's in we offer not too many services, but the thing is we and our small, let's say, department consists of just, let's say, 30 people. 4 of them are dedicated to offering platform services. And if you take those numbers and try to imagine what is the efficiency of those 4 people servicing the entire university, then you kind of get to understand that it's only possible if those tools and machinery that we are using, they are really efficient. And that's what I'm going to talk about later. This is the boring stuff. It's the same numbers that I shortly represented you. I just want to give you an impression that university is a big and complex environment. And I'm representing basically the business customer facing and in developing business software, business architecture. And what my point is to tell you, we love this SimpliVity and hyperconverged because it saves our time, it makes our team happy. I have never basically seen so happy faces, let's say 2 years ago when we first discovered hyperconverged solutions. This is a really interesting part of the how part that I'm actually not going to cover very, very deeply. But this is basically our environment, and it runs on 2 boxes. And what is really fun about that, we wanted to get basically a storage system, but we got an highly available, continuity-ready system that basically does 3 or 5 times more than a single old-school legacy system. And this is the why part. And I have to say that with all the time I've been in IT industry, I can say only good words of the after-sales support of SimpliVity team, because we, as the pioneering customers in this region, okay, respect, thank you for saying that, but we faced some of the glitches of new systems. And we were at times at deep trouble, but with the professionalism that we encountered, we were really happy to see that we were not alone, and we were at good hands. So this is our setup, and this is basically why we love hyperconverged system. And my point of actually is it saves you a lot of time. It saves you, basically you don't need to hire or getting bigger by staff. So that's my message. Thank you for letting to share it with you, and thank you.
The storage I/O consideration is fixed now, so.
Good, thank you.